in your local machine, you have written some code and developed a website which is having multiple pages. Now, these pages are going to have JavaScript, CSS, videos, PDFs, and other assets. Let's first talk about how we can cache the pages on different servers, and later we will talk about the JavaScript, CSS, images, PDF, and other assets, and how we can cache these assets on different servers. What are the best practices and the strategies we must follow while caching these documents? I am assuming after the complete development, you have already tested your website in your local. Now, this is the right time where we can deploy our source code onto the public server because you want this particular website to be publicly available. Now, after deployment, as the end user, when you tried to access a web page, which means you made a request to a server. Now, what will happen as soon as this server gets a request, it will try to process this code. Now, after processing this code, it will generate a web page. The same thing what we were doing in our local. Now, as soon as the page gets generated, the page will get returned to the end user as a response. This process took 1 second to send the response back. Now, if we talk about the other scenario where we have multiple users hitting the server to get the web page. So as soon as the user makes a request to the server, server gets multiple requests. It may be 100,000. Now, what server will do here, server will try to execute this code again and again for every request. Once the processing is done on the server, server will return the web page as a response. Now, point to be noted here, because we are making multiple requests to the server, which means server will take some time to process this request. And after processing, it will take some time to return the response, which means after getting these many requests, we can see the delay of 2 to 3 seconds to get this page back in response. If we have more number of users, then the delay is going to be more. There will be more latency issues to get this page back to the end user. I hope you got the logic here. Whenever we are making a request to a server, server is processing this code and generating a page again and again and returning a response to the end user. What if we can save the generated web page somewhere so that user can directly access that page from there itself in place of coming to the server and process the code again and generate that page. And we do understand we do not wish to generate the page until and unless there is something got changed. Either we have changed the HTML or the asset or CSS or JavaScript. If these things did not get changed, we do not wish to generate the web page. So in that case, our flow will look something like this. So when user try to access a web page and we have placed generated web page somewhere in between user and the server, then once the page is found, page will get returned from here itself. The request will not be going to the server, which means we have saved the server processing time. And in this case, we will get our response faster. Now, where we are going to place this web page, we are going to get the Apache web server, and Apache web server cache the page for us. So whatever output or the page we have generated, we can place this page inside the Apache web server. Apache web server is also having some other advantages, which we will be discussing as part of other videos. But as part of current video, we are only going to concentrate on the caching. So now let's try to understand the flow after having this Apache web server in place. Now users made multiple requests to get a web page. And if the requested page is available on Apache web server will return the page as is, which means our request is not going to the server where our code is deployed. The request is just going to the Apache web server and it is returning from there. Now let's try to see one more flow. So for example, we made multiple requests to the Apache web server. Now, the very first request which went to the Apache web server and not having that page, the request will go to the server where our code is deployed. Now, our server will execute or process the code and generate the HTML. And after generating this HTML, our server will return the web page to the Apache web server. Now, point to be noted here. While returning this HTML file to the Apache web server, it will get cached onto the Apache web server. Why? Because if we are going to get subsequent request after the first one, every request will fetch the page from the Apache web server itself. And then it will return the same HTML file to the end users. Now again, if end users are going to make multiple requests to the Apache web server will smartly return the same web page from the caching or from the local store to the end user. Now here, it will just take the request and return the response. There is no processing time. Here, we will be able to get the page in very, very less time because we are saving the time where we were processing the code, generating the page and returning that page. So here we are just returning the generated page. There is no processing. Now consider if our Apache web server location is in New York and if someone tries to access the page from the India. Now accessing a page from the India will take more time if you are accessing that page from the New York itself because of the distance. And similar to this, if we have our users in multiple countries and they try to access the web page, they will get this page in the span of time depending on the distance, which means if the distance between the user and the server is more, server is going to take more time to deliver that page because that page travel time will also be there. So for example, if user one tries to access this page, the distance between user one and server is less. So user one will get the response faster. But if user three try to access the web page, it will take more time in comparison to the user one. And if user five and six try to access the web page, it is going to take the more time in comparison to user 1, 3, and 2. Now, if we try to have one more server here here or somewhere here, you require resources and infrastructure. It will require some cost to have those servers. So what we are going to do here, we are going to resolve this issue with the help of CDN. CDN is nothing but content delivery network. We can also call it as content distribution network. And CDN allow us to resolve this issue by efficiently fetching data in a short amount of time through the utilization of edge network. Now, what we are going to do, we are going to publish our web page to the CDN. And CDN is having multiple servers around the globe, which means if you are publishing a content on one of the edge network, the same content is going to sync or get duplicate on the other servers, which means if user 8 is trying to access a web page, in place of getting to the server or to this edge network, it will try to fetch this page from the edge network, which is nearer to the user 8. Similarly, if user 5 try to access the web page, it will first check the nearest edge network. If the nearest edge network is there, it will try to fetch the web page from there in place of fetching the web page from edge network, which are available in other countries and continents. But there can be a scenario where one of the edge network stop working. In that case, it will try to fetch the content from the second nearer edge network, which means for user 5, it will see which is the edge network, either this or this one, which is nearer, and it will get the content from that edge network. Now, if you see end-to-end flow where we have multiple users who are trying to access the web page. Now, what they will do, they will make a request, and the request first will go to the CDN, which is our edge network. If the page is available on the CDN, CDN will return the page as a response. Now let's see one more example where users again made a request to get the page from the CDN. But this time we don't have a page got cached on CDN. In this case, CDN will reach out to the Apache web server. And as we can see, Apache web server is having that page. In this case, Apache web server will return the page to the CDN, and CDN will do the same thing what Apache web server did earlier. It will cache this page or store this page, and then it will return the same web page to the end users. Now, again, if the end user try to make a request, they will find this page on the CDN, and then CDN will return this web page. But what if the user reach out to the CDN and CDN is not having a web page, and if CDN will reach out to the Apache web server, and Apache web server is also not having this web page? In this case, Apache web server will reach out to the server where our code is deployed. Now, again, it will execute the code and generate this page. Now, after generating this page, once it will return the response, it will first cache the page on the Apache web server, and then it will cache the same page to the CDN. And then finally, it will return the web page to the end users. And this is how we can cache the pages. Now, let's talk about the strategy we must follow to cache JavaScript, CSS, images, and other assets. As we know, along with the web page, there are several other files and dependencies get loaded, such as JavaScript, CSS, images, and other assets. Let's look at different ways to cache these as well. For example, if a user tries to fetch a web page, now again, this request will reach out to the server, and server will process the code and return the web page. And we do understand with the web page, we are going to return JavaScript, CSS, and logo. And with that, we are also going to return images, videos, PDFs, and other assets. And as soon as we return the web page to the end user, we are also going to return all these assets. In short, if you are loading a web page in your URL, you are making multiple other calls to the server to get these things. And we do understand making these many calls to get web pages and other dependencies from the code server or the origin server will impact the page load time. Now, in this case also, we require one of the place where we can keep all these static files. In this case, we can cache all our static files onto the Apache web server. Now, if the request is coming to the Apache web server, Apache web server will return all the required files from the cache to the end user. And in this case, the page load time get decreased. But you know this, if you are going to use only Apache web server, and if someone is sitting on the other part of the world or far from the server, Apache web server, that person or the user will take a lot of time to fetch this page and its dependencies. Now, suppose if we add the CDN in between, then in this case, the page load time and the required asset time will get reduced. In this case, if any user is making a call to the CDN, and if all the dependencies or the files found as part of the CDN cache, those files will get returned to the end user. And here the page load time will be faster. So let's try to understand one quick thing with the example. To load this particular HTML web page, we are making 6 other calls, okay, to a CDN server. And then we are able to load this page end to end. What if we can cache the JavaScript, CSS, and logo as part of the browser itself, which means locally, okay? Now, if you will load the page and having this JavaScript, CSS, and logo, our browser will not make a call to get these things. It will try to get only these things from the server. Now, why not JavaScript and CSS and logo? We do understand the company logo did not get changed every month or every year, correct? So the expiry time we set for the logo, it may be 6 months or 1 year. But if you talk about the JavaScript and CSS, so for example, if I'm loading any JavaScript as www.abc.com slash js slash 1.js, if you are going to load this particular file and if it gets cached for 6 months, and if you are making a change in the file here, either you have to clear the cache for Apache Web Server CDN and the browser, or what you can do here, you can make these files versioned. What do I mean by versioned? So whenever you are deploying a change in the JavaScript, it will make a version of that file. In this case, the name of the file is going to be slash js slash one hyphen some version unique number.js. Now, every time if you're making a change in the JavaScript, it will always consider the latest JavaScript in place of using the earlier one. If we don't have this versioning, we do understand if we will make any change, and until and unless we don't clear the cache of our browser, we will not be seeing those changes. And we cannot ask user to clear the cache of his or her browser. In place of that, we can just make it versioned. Automatically it will pick the latest version, whatever we are going to include as part of our HTML page. So let me quickly show you an example. Let's go to the Walmart website. Now, after going to the Walmart website, just right click here, inspect element, and search for the banner. Let me refresh the page and search for the banner here. You will see we have one JavaScript file loading and having this unique alphanumeric ID. And if you scroll down a little bit, you will see a header x-cache, which says it is hit, which means this particular file is coming from the CDN. And if you are seeing the value as miss, which means this particular file is loading from origin server, which is our code server. Now, one more thing to be noted here. If you see this particular file, okay, let me copy. Now, if I go to the element, you would see we have an entry of this particular file here. Now, let's take an example. If your page is cache and your file is cache, you are going to get the same thing. But once the page cache is cleared, and if you have any change in your JavaScript, it will create a new version, which means when you are going to load this page second time, and if it has a new alphanumeric ID here, it will load the latest JavaScript file. Similar to this, we have same thing for the CSS files also. So that's where how we are able to cache this JavaScript and CSS for 6 months of time, because this alphanumeric ID helps us to load the latest file from the cache or refer the latest file from the cache. And this is how the caching works end to end. Now, if you talk about the API, let's take an example. If you have a list of countries or any country is having list of states, okay, this data doesn't get changed very frequently. And what you can do, you can cache these responses for 2 months or 3 months of time. And if at any point of time, the number of states or the countries getting changed, you can simply clear the cache and your latest change will be available. So here we have to understand if anything which is not getting changed very frequently, we can catch those things. Now, if you take an example of any commerce website also, okay, and we do understand the product prices doesn't get changed every hour or 2 hour, okay, we can also catch those things because getting every product price from the server, okay, and we do understand we have millions of users. If you talk about the Amazon, they have millions of users. If they are going to make these many calls to the server will get overwhelmed with these requests and it may get down. So here we can create a cache of 30 minutes or 1 hour to cache these details. And this is the way we should be caching things. which allow us to get the page response faster, API response faster. Thank you so much for watching this video. Don't forget to hit like and subscribe for more videos and updates on AI.